Grade, welcome to problem of the day. Walter needs 3/10 cups of pecans to make one fancy dessert. If he wants to make 4 desserts, how many cups of pecans will he need? Well, I could use repeated addition. So this is for 1 dessert. And then I can add, that's 2. This is 3, and so on. You guys have seen this before, but you guys are all probably predicting what I'm going to do. I'm going to say, that's hard. I don't really want to do that. What I could do is just add up those numerators though, and then the common denominator means that 10 will stay in my answer for my denominator. But I know that there's a more efficient way that's going to save me some time and energy, some brain power. So let's do that. I'm going to use multiplication. And as always, there are 2 ways to do this. And as always, I'll do both. So the first one, I'm going to multiply the fraction, which is 3/10. And I'm going to multiply it by a whole number, which is 4, because I'm multiplying that 3/10 cup of pecans by the 4 desserts that need to be made. But on this side, I'm going to multiply the 3/10 of pecans, a fraction, by another fraction by turning the 4 desserts into a fraction, by just putting the whole number over 1. Okay, so here are the 2 options, and now I have 2 strategies. If I'm going to stick with the strategy on the left side, which is the whole number, I multiply the whole number by the numerator. 4 times 3 equals 12. That becomes my new numerator. And then the denominator, 10, stays the same. If I want to do it like the strategy on the right-hand side with fraction by fraction, I just multiply straight across, numerator to numerator and denominator to denominator. So I'm going to have 3 times 4, which is the numerator, which is 12, and then denominators 10 times 1, which is 10. As you can see, both times I'm going to get the same answer, and you guys know from watching these, it's because they're the same problem, just written differently. But now I can be more correct. This is technically correct, but it's an improper fraction, meaning the numerator 12 is larger than the denominator of 10. And I could be more correct by simplifying it. And in this case, if I have an improper fraction, the simplified version would be if I were to change it or convert it to a mixed number. So that's what I'm going to do. In order to do that, I'm going to take the denominator, which is 10, and I'm going to skip count by 10 until I get as close to the numerator, or 12. So I'm going to skip count by 10 as many times as I can to get close to 12 without going over. Well, if I skip count, I'd go 10, and then the next one would be 20, which is too high. So I only get 1 as my whole number in that mixed number. And then I'm going to think about my remainder, or what's left over. So I got to 10, and I need to get to 12. So the difference between 10 and 12 is 2. So that becomes my numerator, and my denominator stays the same. So I have 1 and 2/10. I'm done, right? Wrong. This is also correct, but I could be more correct. I could simplify it 1 step further. So the 1 is going to carry down because that is as correct or as simplified as it can get, but this 2/10 could be simplified. 2, if I were to use that to divide both the numerator and the denominator by 2, I would get a new fraction, and it would be 1/5. So 1/5 becomes my new fraction. 1 and 1/5 is the most correct answer, and it is the most simplified answer. All right, you guys have some different numbers. Walter actually needs 7/10 cups of pecans to make his fancy dessert. Good luck.